'Cause it ain't no lie, baby, bye, bye, bye. So my wife has this habit where if she finds an album or a song that she really likes, she will just listen to it over and over again on repeat. This is fine, except that sometimes this habit kicks in on a road trip where I'm in the driver's seat. Even in that case, this could still be fine if the thing that we're listening to is awesome, like the soundtrack to Wicked. But it's not fine when you're listening to NSYNC, No Strings Attached, on repeat for 8 hours. I mean, once or twice, okay. But for 8 hours? Well, at this point, you must feel like we're repeating all of the same content from DC just with phasers. And you would be right. Almost everything we do in AC behaves the same way as it did in DC. We're just using phasers and impedances instead of resistances. The Thevenin equivalent is no different. We can still represent any linear two-terminal circuit with a voltage source and a series impedance. The process is exactly the same as DC. Hopefully this is a good repeat. Hopefully this is a good repeat like the Wicked soundtrack. One important difference in AC is the formulation for maximum power transfer. The requirement for maximum power transfer in AC is that the load impedance should be equal to the complex conjugate of the Thevenin impedance. The value of maximum power is the magnitude of V Thevenin squared, which is divided by 8R Thevenin, which is the real part of Z Thevenin. So you can see that this differs from DC. To understand this, let's look at an example. In this example, I'd like to find the Thevenin equivalent and P max. We start by finding the Thevenin impedance. By turning off the voltage source, I have a 10 ohm resistor in parallel with a J10 ohm inductor. This combination is in series with a negative J4 capacitor. Combining these together, I'm going to get 5 plus J5 minus J4, or 5 plus J1. I'll point out that the real part of the impedance is R Thevenin, and the imaginary part of the impedance is X Thevenin. We care just about the real part. To find V Thevenin, what we do is we assume that at the load we have an open circuit. When we do this, I can use voltage division to find V Thevenin. V Thevenin is J10, the impedance we care about, divided by 10 plus J10, the sum of the impedances, multiplied by the source voltage, which is 5, and that gives me 3.536 angle 45 degrees volts. The condition for P max, maximum power transfer, is that ZL is equal to the complex conjugate of Z Thevenin. Finally, calculating the maximum power, which is the magnitude of V Thevenin squared over 8R Thevenin, I get 0.3125 watts. So you see, repeating stuff isn't always a bad deal. Sometimes it works out in our favor because we get to use the same techniques we already understand. Now, go and share your circuits knowledge with everyone. That'll make you super popular. Lar. As always, thank you so much for watching this video. If you enjoyed it, I would love it if you would subscribe. You can find me on Twitter or Instagram at BD McPheron or at DM Explains. This is Dr. McPheron. Okay, bye.